I have one more thing to talk to you about from the review, and that is the GCF of two numbers. Let's take 36 and 60 as an example. I think you can see it.
Yeah.
And I'm going to use just primes. So I'm always going to try and start with either 2 or 3. 36 is divisible by both 2 and 3. But 2 times 2 is 4, times 3 is 12, times 3 is 36. So here are my primes. 60, that was a little trickier. 2 times 2, again, is 4, times 3 is 12, times 5 is 60. Now I have 3 pairs. So I can take those 3 pairs and use them to find the GCF. 2 times 2 times 3 is 12. So the GCF of these two numbers is 12. GCF meaning greatest common factor. Now this is another one that we did sometime early in the chapter and maybe we've forgotten a little bit about. But 44 plus 66. What would be the GCF that I could extract from both of those numbers and I could rewrite it as a distributive property problem? It looks obvious that it's 11, but there's a bigger number, so don't get stuck with the obvious. Look for a bigger number. That would be 22. So I'm going to divide 22 out of 44, and I get 2. I'm going to divide 22 out of 66, and I get 3. So it's 22, open parentheses, 2 plus 3, close parentheses. What about this one down here? 49m plus 14. What would the GCF be in both of these, 49 and 14? Probably 7 is popping out at you, especially because it's written right here. So we would take the 7 out of the 49m. Do not forget your variables. And we'd have 7, open parentheses, times 7m gives me the 49m. And then we've got 7 times 2 gives me the 14. These are not like terms, so this is as far as you can go. You cannot add those two together. And now I am actually finished.